All right, things look like they are stabilizing here on our attendee list. So good afternoon, everyone. My name is Dr. Eric Turing. I'm the Senior Vice President for the American College of Veterinary Preventive Medicine, and I want to welcome you to the webinar today. Our webinar is sponsored by the American College of Veterinary Preventive Medicine and our partner organizations, the National Association of Federal Veterinarians, the American Association of Food Safety and Public Health Veterinarians, the National Association of State Public Health Veterinarians, and the U.S. Animal Health Association.
Today I'm going to be talking about the longhorned tick, Theileria orientalis, and the bovine. I said that I can introduce myself since I often introduce the other folks. Who am I? I am a food animal veterinarian, first and foremost, and I am also a veterinary educator. These are students out in Southwest Virginia. I worked at the Virginia Maryland College of Veterinary Medicine for 13 years, and now I'm at the Clemson College of Veterinary Medicine. I am a researcher of infectious diseases. I do Theileria research. I've also done crypto research in dairy calves, which is kind of a little bit different for right now. And I like to consider myself a public health unofficial. So I talk to a lot of beef producers, like at National Cattlemen's and things like that. And I am a member, of course, of the American College of Veterinary Preventative Medicine. So here we go. I'm going to move this over here so it's out of y'all's way. There we go. Okay. So we've got some objectives here to kind of know where the cattle Theileriosis and the longhorn tick are in the U.S., to kind of look at some of the evidence about Theileriosis in cattle in the U.S. as well as other countries, describe some of the challenges in treating it, evaluate the difficulty of controlling the longhorn tick in relation to other cattle parasites, and try to appreciate the complexity of the USDA regulatory situation of both parasites. Just an FYI, I'm focusing this talk a little bit more towards some of the regulatory situations and a little bit less of the actual clinical stuff that I'm doing. But if you are interested in that and happen to be an AABP member, next Thursday, I will be talking more about the clinical side, going into a little bit more of that and a little bit less of the regulatory piece next Thursday. I do want to point out this yellow here where it's an anaplasmosis in there. Anytime you see this bright yellow, Theileriosis and anaplasmosis have some similarities, but they also have some differences. So when you see this, I'm going to draw a difference between anaplasmosis versus the Theileriosis. So this is just kind of like, oh, this is Theileriosis, but then, oh, FYI, here's where anaplasmosis is a little different. So that's when you see that yellow. That's kind of what you'll get to there. So who are we dealing with here? So Haemaphysalis longicornis is the longhorn tick. It is in the literature, often the Asian longhorn tick. There is some changing, and so we're just trying to be good for everybody. We call it the longhorn tick, but it is Haemaphysalis longicornis. These were actually the first two ticks taken off of cattle at the Index Farm when it was first in early 2018. So that's these guys here. Theileria orientalis is a intracellular protozoan, and it makes these little purioplasms in the red blood cells that you can see here. And they do look a lot like anaplasm, so we'll kind of talk about this. But this is the first blood smear that was published in the Oaks paper from 2019 of the first from the index herd. So this is Theileriosis in cattle is really the tale of two parasites. The first parasite is the longhorn tick, and it interacts a lot with the environment as well as all these other animals that you'll see here in this little picture in the environment. And so it has a relationship with the environment and it has a relationship with the bovine. The second parasite is the intracellular protozoan that is Theileria orientalis. It has a relationship with the tick, but it also has a relationship with the bovine's red blood cells. And so everybody knows parasites are tricky enough, but this disease is really a balance of two different parasites, and so it does make it quite complicated. So when we're talking, it is a tick-borne disease, and so when we talk about the selected tick species of veterinary importance to cattle in the United States, you can see, cattle tick is down, oh, sorry, down here. And so we don't have that one up, thank goodness, except for the tick riders along here. The longhorn tick is this kind of reddish pinky color here. And you can see it's kind of all this way. Now, the interesting thing is you'll see this big giant bit of purple here. So the other colors are the ticks that carry Anaplasma marginale. And so you can see that there is an absolute overlap of the two ticks and where they live in the United States, which means anytime you think you might have an anaplasma problem, it may be Theileria now, but anytime you think you might have a Theileria problem now, it may be anaplas. So you often have to think about looking for both of those things. Okay. Okay. So the Haemaphysalis longicornis, or let's talk about reproduction. This thing, this girl, and I say girl for this particular reason, she is phenomenal. She reproduces by parthenogenetic reproduction. She doesn't need a male. She herself has done it all. So, of the millions of females that have been found and identified in all stages, larva, nymph, and adult in the United States since 2017, one male nymph has been found. That's it. Otherwise, it's all been done by her. So that is quite impressive. She is also a prolific egg layer. One female lays 2,500 eggs a day. And so we're talking about millions all by herself, and then she lays her one egg. And so it really is quite remarkable. You'll also see this is a picture from Dr. Eastwood at Virginia Tech. And so these are all Haemaphysalis longicornis. Like this is one blade of grass with like 10 of them on there, right? So now we're going to get to a little bit to her ecology, which in itself is also amazing. So you'll see the previous picture showed that swarming behavior, right? This picture here also shows that swarming behavior. This is a calf. This picture is from Dr. Tom Lavelle. This was a calf down in Virginia. There are all three stages of the Haemaphysalis longicornis on this one animal. There are larvae, nymphs, and adults. They're all females, but they're all here on this one animal. And this is what they do. They like live in this spot in the pasture, and she makes millions of herself. And then an animal steps into that spot, and then wham, they're all on her doing their thing. She is an aggressive biter, and she is an aggressive feeder. She is the only tick that I am aware of. Now, I'm not an entomologist, so maybe another entomologist, but the ones that I've read about, she is the only tick that goes back for seconds. So most ticks, if they're feeding on an animal like bovine, and they get like half a blood meal, and then the bovine happens to wallop them off or something with her tail or whatever, and off she goes. Well, most of them sit on the ground and they're like, oh, woe is me. I guess I will only make half the number of eggs because I fed and I only have half my belly full. Not the longhorn tick. She finds a blade of grass. She crawls her way up that piece of grass. She quests again until she finds another victim, which she feeds on until her belly is full so that when she falls off, it's her choice and she can make 2,500 eggs every day. So she is a remarkable creature in a horribly bad way, but quite remarkable. Okay, I'm trying to get why can I not? Okay, perfect. So one thing that we do know, there have been multiple introductions of the longhorn tick to the United States. This is a recent paper from 2025. So originally, we thought we found the tick in 2018, in May of 2018 in Virginia off that index farm, which is actually kind of somewhere like one of these green dots. But after we had realized that it was the Haemaphysalis and identified it, they started going back to the ticks that had been saved. And the very first Haemaphysalis longicornis that was identified in the United States was from Tyler County, West Virginia, where this green star is. And it was actually found in 2010, but it was misidentified. as something else. I don't know what, but it was misidentified. So we know that this was the first one based on all the that we at least that had been turned in and had been identified. But you can see that there are three haplotypes. This H1, which is really interesting because this H1 up here, this was a sheep, which in 2017 it made the news because this sheep in New Jersey, of all places, I didn't realize there was a lot of sheep in New Jersey, but was covered with these ticks because of their swarming behavior, and they were identified to be the Haemaphysalis longicornis. So everybody was like, ah, this is the first time we found the tick in the US. Then it was on the sheep though, and sheep don't get Theileria, so it wasn't, I mean, it's a problem because it's new to us, but she didn't carry disease. Then when it was found in 2018 on those cows that we had already diagnosed, sorry, with Theileria, now it kind of put the picture back into sense. So this is H1, this is technically H2 down here. There is an H3 that came in here, and then they've kind of gotten together and done some breeding as ticks do, which is interesting because again, she's not breeding, she's parthenogenetic, but she is definitely sharing her genetics with other females in their weird parthenogenetic fashion. And so, yeah, but it's not breeding. It's strange, strange stuff. But as you can see, though, besides this one here, right, it sort of makes sense. There's a lot of shipping, right? Here's at the end of, that's a Delaware River. This is coming in New York, and there's a lot of shipping. And so it's not surprising that the ticks came in on some sort of shipment of something from Australasia somewhere. So you may say, well, how did she come in for those ships and get to these other places? And I would be surprised, except for the fact that besides being some amazing biology and ecology, the Longhorned Tick has a rideshare program that is better than Uber or Lyft. These are the mammals on the east coast of the United States. So, like, these are just kind of the standard mammals. Um, and then there's some birds over here because I have to add those in. And according to the USDA, when we were tracking where these things were coming in on, the longhorn tick has been found on all of these mammals that you see here. And the bigger the star, the more the longhorn tick has been found. It's also been found on all of these birds over here. And actually, this is probably 10% of the birds. I just only put the birds that had like 10 or more times because I got tired of writing down a bunch of birds. But there's actually a ton more birds. And it's everywhere. I mean, the rideshare program, this thing just travels. So I get that cattle is a problem, but I don't know about you guys, but it's really hard to keep deer out of the field. The fox, things like that, all those things are difficult. So just the tick itself has an amazing rideshare program. So now we're going to talk a little bit about Theileria. So Theileria species, they are primitive eukaryotes, and I think that's something that we forget sometimes. And so I'm like, I hate to scare you back to our, 10th grade biology, but the prokaryote is that really single-celled, not even single cell in the sense you think about virus, fungi, and bacteria, right? They're all prokaryotes. They're very primitive. Bacteria are pretty slick, but still, the eukaryote, now we start to get, organelles and all sorts of things happening. Sorry, I turned this off and I don't know why. Anyway, all sorts of things happening in the eukaryote. So these protozoa are single cell eukaryotes. They're primitive, but they are still eukaryotes, and that is really important. They are a member of the group called apicomplexan parasitic protozoa, which are paraphyletic protozoa, which paraphyletic is another big giant word that I don't like. But it basically means that they have a common genetic ancestor. However, they actually have very little in common with each other in terms of modes of action, how they work, how they infect, and therefore how they can be treated. So Theileria is the orange right here, and the common ancestors of it include Plasmodium, which is malaria, Eineria, our coccidia species, Sarcocysts, Toxoplasma gondii, and Neospora. And so even cryptos in that same family a little farther back. So I mean, you guys know those bugs, right? They are very different. They all are difficult to treat. So it's a hard bug because it is a eukaryote. So when you look at the different types of Theileria species similarities, they all have very complex life cycles involving ticks as well as some sort of vertebrate host. They are transstatally transmitted through their life stages. So through the saliva glands, it goes from the eggs. The larva. If a larva bites a positive animal, then the nymph and the adult are also going to be positive. And each of those stages has to feed in between. So there's like three opportunities for them to get it, but there's also three opportunities for them to give it. There is no transovarian transmission, so the eggs on the ground do not have, they're not positive for it. And the tick vectors, besides just being a vector, the tick vectors amplify the infective stage. And this is a really important piece of their life cycle. So here you can see, here's this side's the tick. She bites, she sucks the blood, it goes into her gut, then the infective agent goes from, her gut to her saliva gland, where then it like turns into millions of them, so that when she bites the next victim or vertebrate host, she's not putting in one or two, she's putting in millions of the infective agents right away. And so that is, again, an interesting problem. But remember, the tick vectors amplify. It's not just that they carry it. So that's a difference when you think about mechanical vectors, right? Like the mechanical vectors, yes, they can carry it, but they don't amplify it. And that's a big difference. Some of the differences are this. There are basically two types of Theileria. The original kind are called transforming Theileria. These are transboundary diseases, foreign animal diseases. They are in Africa and India. They rewire the white and red blood cells so that particularly the white blood cells are like they get very large lymph nodes and it's very cancer-like. It's not cancer, but it's very cancer-like in the sense that they proliferate and they prohibit apoptosis. These diseases also have very high mortality. T. parva is up to 100% mortality in the bovine species, and annulata is 40 to 90%. So huge issues with mortality, not just illness, like mortality. So they used to call the Theileria orientalis, they used to call it benign. They've been on all continents except for Antarctica. There are like 11 genotypes with varying severities of clinical disease. Most virulent genotypes, if they are virulent, they destroy the red blood cells. So the two that are the highest in virulence and kind of most known about of the 11 genotypes is Ikeda and then Chitose, or Chitos. I'm not exactly sure, but it's in the US, we do have both, but we definitely find Ikeda much more than we find the Chitose variety, but it is here. So anyway, again, it's a destruction of red blood cells. So clinically, this is what our beast looks like. The acute syndrome has a 10 to 28 day incubation. That is a little bit more condensed than anaplasmosis. For example, anaplasmosis is more like a 6 to like 45. It can be a little bit more variable. The clinical signs are fever, ill thrift, increased respiratory rate and effort, anemia, icterus, abortions and or death. Typically, you don't have abortions and death. Typically, you'll either have an abortion issue or you'll have some cows dying. Mortality is originally we considered it to be less than 5%. Given the amount of Theileria that is now in the US, I honestly think it's less than 1% at this point. in terms of the amount of infected animals. It sucks for the farm that the cows die on, but it is numerically less than 1%, if not even less than that. Um, Anaplasmosis, unfortunately, has all of these things, right? They fever, ill thrift, all that looks the same. They do have anaplasmosis does have a higher mortality rate than Theileria does, but it really looks quite the same. So how do we diagnose this thing? Um, Problematic as well. Sorry, I don't really have any good news today. In order to have a definitive diagnosis, you need three things. You need the animal to be PCR positive to orientalis, Ikeda, or ketose A with a cycle count on the PCR, it's a quantitative PCR, of less than 24. Okay. This cow also needs to be PCR negative to Anaplasma marginale, which most of the labs are doing a two-part, send the one sample, they get tested for both at the same time. Then the second PCR determines genotype. However, that in itself is not enough for me to tell you that your animal is sick from Theileria. If the PCV of that animal, even if she is positive, is not less than 20%, your animal is not sick from Theileria. Yes, she is a carrier. Yes, she has Theileria, but it is not making her sick, and it is not causing whatever clinical signs you're seeing if that PCV is not less than 20%. The animals then remain carriers. They used to think in New Zealand, particularly in New Zealand and Australia, have had this disease for almost 3 decades now. We used to think that it would recrudesce in the positive carriers, in times of stress like parturition or transportation, but they've actually seen in New Zealand and Australia very little evidence of recrudescence at all. So that's kind of a good news. This cow, it was positive. Her PCV was 11 and her cycle count was 18, and she did genotype to the Ikeda, just for you to know. I will say that some people talk about using a smear. We're going to talk about that a little bit later, but veterinary pathologists in studies have been, like, these are board certified veterinary pathologists, have only been able to detect a true positive with a blood smear somewhere between 56 and 72% of the time. So it's not the best. Unfortunately, right now we need to do the PCR test. So it's really important to me that and when I teach students, we really need to practice evidence-based medicine. And unfortunately, right now, I think there's a lot of not hysteria, but I mean, close to it with Theileria. You see headlines of cow killing disease, killer tick, I mean, you're seeing all these things, and it is very, very stressful to the producers for sure. But we really need to pay attention to what the evidence from Australia and New Zealand, who've been dealing with this, are showing, and what we found here in the US. Because I know it just reached kind of out west, and there are a lot of cattle out west, so I understand that monetary concern. But actually, several of us have been studying this disease since 2018, because it's technically been in the US since 2017 in cattle, but we really didn't figure things out until the beginning of 2018 when we found the tick, and then we've been kind of cruising with it. So there you go. So this is where it first started. So this was the spring of 2018. This pink color here, pinky salmon color, that is Ikeda. And then occasionally you'll see kind of the ketose coming out in the more striped. And in spring of 2018, here's our sheep up here in New Jersey, which was 2017. And then here is the farm where we found Theileria orientalis first, and then the next spring. So we found that in the fall. And then in the spring, we found the Haemaphysalis longicornis. And then this is until now. Okay, so this is kind of happened. So you can see that the Haemaphysalis longicornis kind of really spreads out first, and then comes the Theileria in the cattle. So this is Theileria only in cattle. Okay, so this is as of June 2026, which was just 2 days ago when I finished my search. I will tell you that this is what is available only through like literally like Google searching. I don't have ins with labs and stuff like that. So this is just what I am able to find by searching extension sites, state sites, all sorts of different sites. You will see that these two here in Kansas are obviously quite concerning. Both of these cases, they do have the tick, but both of these cases of Theileria were imported cattle. And most recently, I think in January in Nebraska, they don't have the tick yet, but they did find Theileria again in imported cattle. Um, the tick, however, is not always been on cattle. The tick is found by drags on all sorts of other animals, but the Theileria orientalis is always in cattle. So, two states to be concerned about, of course, are Michigan and our Indiana. They do have the recent discovery of the tick, and they do have a fair bit of cattle compared to some of these upper Northeast states. Okay, so this kind of goes with what we have found in Virginia. So we did some convenient sampling at livestock markets starting in 2018. We had every livestock market that, like every VDAX or Department of Agriculture employee or, inspector that was visiting the market on their day to visit the market, they drew 5 samples of blood from whatever 5 cows that they could. And now at the bull test station, we tested these bulls that were coming to two test stations in Virginia on intake, and we also tested them when they left. So you can see that in 2018, it was like less than 2% of the cattle. And in 2024, more than 80% of the cattle that were being convenience tested in Virginia livestock markets were positive for Theileria. Now that is, again, these are livestock markets that people are selling cattle that they're, essentially not doing well, which is like, okay. But the bull test stations, these are folks, high dollar bulls. These are the ones that they feel the best about that they're sending to be tested. These are the results from testing positive at intake. So in 2019, I know for a fact at location B, we had one bull test positive. By 2024, it was 82% that tested positive on intake. So it spreads like wildfire, and that's what I mean by that first farm and some farms that have experience with this. Yes, they may have 5% in a farm. So if you've got 50 animals, right, like, or 100 animals, like 5 of them might die, or you might have 5% abortions or 3%. But the reality is that there's a lot more positive cattle out there than are dying, because that's why I think that mortality percentage is down lower. So some of the other strange data that we have. So this is one client, this is personal data. It's one client in Virginia. They have 12 herds. They're spread all up the country. We tested every single breeding female in 2019. That's about 2,500 head. FYI, before this, there had been no clinical cases of anything that we would have tested for it, nor there was any outbreaks of morbidity or mortality that were like, we didn't know the cause of. Like, actually, we had none, but like, we didn't even have any unknown things happening. You can see that one herd was nearly 99% positive. Many herds were 0, and then we have a couple herds kind of in between. So even from 2019, this herd, which is up near that index farm, was nearly, I mean, it's 100% positive. It is now. Back then, there was a couple still escaped, but now it's 100%. So it kind of goes with some of the strange data from Australia. So Eastern Australia has had Theileriosis in their cattle for a while, but in, I think it was like 2019, they had some outbreaks in Western Australia. They were typical clinical signs and pathology. It turned out to be genetically identical to the orientalis ikeda that was endemic in Eastern Australia. But this is 5 different farms that they went to. And these are cow-calf operations, similar to the ones here. And you can see that, first off, they didn't find ticks except in 40% of the farms, right? And huge range. Like 2 of the farms they found ticks on, one of them had the lowest amount of sick, on the lowest end of sick cows, and the other one had the highest amount of sick cows. Um, and then a decent number of dead cows, right? Like, so it's huge variation because, and I think this goes back to the fact that this is a 2 parasite problem. And so you have to think about how many ticks there are, and you have to think about how many parasites there are, and then you have to think about how many animals and what the ecology is like. Is it in a swarmy area? Is it not in a swarmy area? There's a lot of variables. Over time in Australia, what they have found is that originally this started out with the adults are the orange, and so it was the adults were getting sick, right? But then it kind of switched, and now it's the calves that get sick more because in beef cattle, we really counsel everybody on, we want a defined calving season, so we have a defined breeding season, which is how you become profitable. But the problem is that yearly calf crop is naive and is a renewable source of naive animals. And that is very different than anaplasmosis. Anaplasmosis, though the calves that are less than 6 months old and get positive, they're asymptomatic. They're not bothered at all. Theileria, the calf that gets Theileria at less than 6 months of age, is totally susceptible. And that's why we start seeing more of them dying than the adults. Okay. How about in New Zealand? So this is where Kevin Lawrence has done a lot of work, and basically that it appears to be that once the effects on production and reproduction appear to be minimal once the animals have reached the chronic asymptomatic carrier phase of infection. So this is a dairy farm. And they are pastoral dairy farms. So they had one farm that was 100% positive when they first checked. They had a 25% farm, and they had a 2% farm. And of course, the farm that had the highest morbidity and mortality was the one right in the middle. So not very helpful at all. What do we know about beef production or reproduction effects in the US as of now? And this is where this is the data, but I'll get a little bit more into it for the AABP. In heifers from when they're weaned to mid-gestation, IKEDA positive heifers for the 3 years of 2020 to 2023 had no significant differences in their average daily gain, whether they were fall bred or spring breeding heifers, or at any period. If we looked at the periods between when we weighed them, no period had a difference in average daily gain. They also had no difference in their ability to get pregnant. So we AI all of these heifers once, then they're put with bulls, and we ultrasound these heifers twice for pregnancy, and then that's early so we can figure out AI versus bull because a lot of these are under research. And then we also keep records of like post after the fact once the calves hit the ground. There's no difference. They all do just as well getting pregnant on AI versus bull or being open. There's no difference between if they're fall or spring breeders. So then we looked at the bulls. So remember, I looked at those bull tests. So at the bull test, we were able to test them on intake, and then we tested them again at the end. So we have not just positive and negative. We have positive on intake, which means positive at the end. We have negative on intake and negative at the end. And then we had the ones that came in negative on intake and went out positive, even though these bulls are maintained in essentially what is dry lots. So we have kind of those 3 groups. And again, for those 3 years at 2 test stations in Virginia, run at different times of the year, or actually 4 years, there was no difference in average daily gain. at the different test stations or for any period, and this is junior and senior bulls. And the breeding soundness exam results, there was no difference in those being eligible for it. So they gained just as well or did not gain just as well. Had nothing to do with their IKEDA positive status or their ability to perform and get a satisfactory score on their BSE. Okay, so what about dairy? So we don't have a lot of good dairy information yet in the United States. I have some data that I'm getting, but I don't have it right now. In pastoral dairy systems, there, for example, in Australia and New Zealand, where the cows are out on pasture much more than they are here, there is evidence of decreased production, milk volume, milk fat, with IKEDA, even more so than like a mixed IKEDA ketose, because they do have more mixed infections. And reproduction shows evidence of production parameters, including a decreased conception at first service, a longer time to conception, and decreased pregnancies from the first heat. In Japan, however, they use a house dairy system much more like the US system. They don't have much pastoral. And so there, with IKEDA positive, there was no difference in 305-day milk yield, no difference in the time to conception, and no difference in the prevalence of fresh cow diseases. Again, these cattle are housed inside. Remember, they're only on pasture for a short amount of time if they are, just during their dry period. And so they just have much less exposure to those ticks. Okay. So at this point, we're probably a little frustrated pulling our hair out. I totally get it, and it's only going to get worse. Antibiotics. What's been tried? Oxytetracycline failed. It is, however, remember, effective against anaplasmosis, and we even use it in a veterinary feed directive using chlorotetracycline, use the same family. However, it does not eliminate the carrier for anaplasmosis. So just FYI, remember, will not eliminate. Telithromycin has been tried in Australia. That failed. Of course, it really isn't a surprise, right? Because it is a protozoa. It is not a bacteria. Anaplasmosis is a bacteria. So, okay, it's a protozoa. So let's look at our antiprotozoas. What's been tried? Toltrazuril has been tried in Australia, and it has failed. Imidacarb has been tried in Australia, and it has failed. Now, imidacarb does work for canine babesiosis, which is also apicomplexan, and equine pyroplasmosis, which is Theileria equi. So it's a Theileria, and imidacarb works for them. It takes a fair bit of treatment time, but it doesn't work in cattle for the Theileriosis orientalis. Okay. So we have another one called buparvaquone. So it is not approved for use in the United States. In New Zealand and Australia, it has been used for orientalis IKEDA. And in India and Africa, it is used also for the transforming Theilerias, those are the ones with really high mortalities. So I'm kind of really going to talk more about what the New Zealand and Australia situation is, because that's more of what they're dealing with as well. It does control symptoms and reduces parasitemia, but only in the acute stages. Okay. So what that means is they used a field anemia card that they made so that everybody wouldn't have to test. And basically, I talked to two veterinarians in New Zealand, and if they caught an animal at the 15 to 19% PCV, so they got a PCV of 15 to 19, they could use buparvaquone and it would work great. They would not die. If the animal had a PCV of less than 15%, they still used buparvaquone, but that animal generally needed a blood transfusion to survive. Also, like, they couldn't just buparvaquone. They said maybe 50% would save, but otherwise, if you really wanted to save something, it definitely needed a blood transfusion at the less than 15. And if you were down into the 10 to 10 range, that absolutely, if you want it to live, it needs a blood transfusion. We also know that it does not eliminate the carrier state. Just recently, ours out in Washington did a study. They used it at the labeled dose. They used it twice at the labeled dose and it still didn't do it. They used it at 2.5 times the dose, and then they used it twice at 2.5 times the dose, and it did not eliminate the carrier animals. It has very long withdrawal times. In New Zealand, it's 47 days in the milk, and it is 18 months in the meat. Now, in India and Africa, it has a label on it of 42 days. I don't know about y'all, but if I'm going to eat a steak from someplace that's not the US, I'm probably going to lean more towards New Zealand and Australia than due to the better food safety systems versus India or Africa. There are also some export issues with it in the sense of some countries will not accept your beef if you use this, so it's not something to be taken lightly. The last thing is, since 2010, where they have been using it in India and Africa for these diseases that, have 40 to 100% mortality, there are already multiple documented resistant strains of the transforming Theileria species that have developed on the Asian subcontinent and Africa. So again, these things are parasites. They are really, really good at becoming resistant to whatever we throw at them. So it's certainly not the solution in the bottle that we're looking for. So then I'm saying, okay, well, we've got some vaccines, maybe. There's been a lot of studies using the pure plasma surface proteins as a subunit vaccine. Every single one has been unsuccessful to date. We do know Bufali is another one of the 11 genotypes that there have been some studies that if an animal gets Bufali prior to its exposure with orientalis, it actually protects it from getting orientalis, and Bufali is truly benign. So you sort of think, okay, is there a potential, kind of like we do with anaplasma and the calves versus an adult, some sort of type of like modified live exposure, but then at the same time, we're actually like giving them an infection of orientalis bufali. So I'm like, I don't know how I feel about that. In Australia, they have done some work where they can generate resistant livestock through genetics, kind of like scrapie resistant sheep. So that is a potential, but again, that's going to be a fair bit of work into that. There are some tick vaccines out there, and the next slide I'm going to talk about one in particular, but in general, the tick vaccines, there've been only two known commercialized tick vaccines, and they were against our microplus. But both of those in history had very limited efficacy, and therefore, like one of them is no longer even marketed. They do reduce feeding time. They may increase the mortality to those ticks. They may decrease ticks in the environment, but the ticks still have to attach and they still have to suck the blood, and therefore they are still injecting these animals with millions of infective agents. I do know that there is now one, and I have spoken. These guys called me, and we talked about what they're doing, and honestly, I struggle with this because I know that everybody wants a tool to address the tick challenges, but part of they talk about safe and efficient vaccines. Efficient is not effective. And that bothers me because efficient is not effective. And they asked, this is the small print on their ad that says potency and efficacy of prescription platform products has not been established. And I've also talked, unfortunately, to the FDA, and any autogenous vaccine or this type of vaccine, like you, unfortunately, all you have to do for it to be labeled is to prove that it is safe, to prove that it's not going to cause any harm. You do not have to prove that vaccine is effective. Like even all the pink eye vaccines that are autogenous and all the companies, they make pink eye vaccines, they don't have to prove they're effective. That's problematic for me. My problem is if you think you're giving the producer a tool, an ineffective tool consumes a producer's limited resources. It also leaves the producer with a false sense that they are doing something helpful or productive, even though it's easy. It's not as actually as helpful as maybe the hard stuff of going out and roping off some of your pastures or feeders before breeders, or I mean, some of these other tools that we have. So I struggle with this, and I don't believe that the science is there. So, parasite control. This is a great quote from Wilson, the entomologist. Parasites are predators. They eat prey in units of less than one. I'm going to speed up a little bit through this because you guys know all of this stuff. Practical tick control is integrated. You need to use multiple kinds, multiple classes, et cetera, et cetera. Look for the ticks, remove the ticks, get them identified. Environment. Reduce the contact of pasture with animals in the edge of the woods, reduce large weeds. One thing that they do in New Zealand is they do consider using less valuable animals to clean the pastures, like they use sheep. I thought you could use like feeder cattle before you put your breeders on so that they kind of get all the ticks off before you put them on, something like that. Again, we have three classes of tick control, the macrocyclic lactones, but you do get increased resistance to your gastrointestinal parasites. Organophosphates, but again, they are toxic to cattle, humans, and you get some environmental contamination. And then, of course, the pyrethroids, pyrethrins, plus their synergists, but there is a fair bit of ectoparasite resistance to them. What can we learn from New Zealand? The movement of parasitemic cattle to areas with a competent vector and naive cattle spread the disease. The longhorn tick density in the new area is influencing the expression of that Theileriosis in naive cattle. What they have found is that when there's like kind of a medium tick density, this low tick, that's when you get sicker animals, whereas when there's no ticks, you don't. And then when there's high tick, it actually, you get a mild disease, and typically you go to that rapid endemic status with them all being testing positive. Current issues, just because an animal is positive does not mean they're sick or died with it. Unfortunately, our only real option is to control what can be controlled, proper pasture management, appropriate biosecurity, maximizing herd health, excellent bovine husbandry. None of this is new, right? There are some issues for cattle populations. Reporting is a bit of a mess. This is most recent, this is from Kansas, and it's from the Kansas lab. There's this positive out here in Kansas, in California, and I cannot find hide nor hair of it. This is from Tennessee. It shows that, like Indiana shows that it has longicornis tick and Theileria orientalis. I cannot find any proof of the orientalis. That doesn't mean it's not there. It just means that the world doesn't know about it. We kind of have a lack of systems thinking for the U.S. industry and food production. We have a lack of respect for the longhorn tick. She is a powerful beast. And we have a lot of short-term thinking going on. And then the last bit, which I think is really interesting for this audience, is the regulatory mess. March of 2020, they put out sorry, there should be a D there. The NILRAD is what they call it. And so if you look here, notifiable bovine diseases did not include, this was just the foreign animal diseases. This is the national list. This is what's off of its page, and it talks about notifiable, immediate reporting required by animal health professionals, and then you have your monitored diseases. The definition of an animal health professional includes, but not limited to, vets, diagnostic laboratorians, which I do not know is a word, biomedical researchers, public health officials, animal health, et cetera, et cetera. Then in January 2023, the World Health Organization changed their terrestrial animal health code, and they added orientalis ikeda and orientalis ketose to their list. So the US kind of then said, okay, well, we've got to kind of adjust to that because we're a member of the WOHA. And so they opened up the rule, the proposed rule for the national list of reportable animal diseases, and they opened it up and said, okay, opened it, then they closed it on September 27th, and September 27th of 2023, this is the end. The rule is on hold. It is not codified at all. So it's just like on hold right there. Then they put out a case definition in December 2024 from APHIS, which is okay, but they put down here that it's a notifiable disease, but this is not codified. And some of the statements aren't exactly correct. So like mechanically it can, but it's far less. It's not done transplacenally. We don't use antiparasitic drugs except for the foreign animal diseases. You cannot use a serologic test for anything but the foreign animal diseases. And you don't want to use blood smears to diagnose because it's not very helpful. So the final news is that it is notifiable voluntarily. It is a voluntary U.S. national animal health reporting system, which now does have Theileriosis orientalis on it, but it is voluntary. So what that means is that it is not codified. It is not codified. So this is the animal health professional. The only thing that is codified is through the National Veterinary Accreditation Program, which is a voluntary program of veterinarians. And that is codified in here that the only people have to report are accredited veterinarians, and they need to report TB, brucellosis, pseudorabies, scrapie, or they need to report a high path or a true foreign animal disease. As you can see, Theileriosis is not on the record. However, states can put it on, so check your state. In my research, I've only found Michigan thus far, but I did not check every 50 states. The Longhorned Tick has no federal reporting, but most state labs will identify them for free. Reporting is recommended and it is best practice, but it is not without risk for the producer. So it really needs to be a conversation with them. You can't just go and report because there's a lot of things happening in the beef world that you can actually harm them economically by doing that. So in conclusion, this is what I got. It's kind of how I feel. I just want to say thank you to these folks who have kind of done a lot of help for me. And I am now going to take a breath.
Okay, we've got several questions here. We'll start at the beginning. One of the first questions was regarding the tick itself. And the question is, how do the tick progeny differ genetically from the mother?
That I don't know, because somebody was asking me about that the other day. My impression is that they're not like armadillos and they're not like clones of each other. But I don't know a lot about things like parthenogenetic. I don't believe they're clones, and there is some mixing of DNA, as you can tell by the different haplotypes, but I'm not enough of a geneticist or an entomologist to know.
Okay. Next question that came up was regarding movement of cattle out of endemic regions. Can you comment? Are there requirements that exist out there?
So there are no national requirements. Some states did originally talk about putting state requirements into their health certificates, but I actually have not seen them be out there. So at this stage of the game, besides, of course, the standard CVI thing that says you are not aware of this animal having any, infectious, contagious disease, as far as I know, there are no states that are requiring testing as of right now.
A couple questions regarding the surveillance of the tick. Is anybody working with wildlife rehabilitators to involve them in surveillance?
Oh, yes. Yeah, no, Denise Bonilla of the USDA, prior to New World Screwworm, she held a monthly meeting 9 months out of the year where we all got on about the longhorn tick, and like all the states got on and everybody talked about like all the states doing their dragging, working with the different wildlife, working with the CWD people for the deer, all sorts of things going out there. And so we've done several like surveillance things of like getting information, and that's been doing good. Then Denise got pulled away, but now Becky Fry Trout Trout Soul Fry. I can't remember quite the direction it goes in, but she's at Tennessee. She has taken that over, thank goodness. So now we still have another place that we get together, typically again once a month, except during the winter time. And we all the states get on and talk about all the different things so that we at least sharing as much information as we can about the longhorn tick for sure.
Um, gonna gonna put you back on the genetic spot here.
I'll try my best.
So someone asked, can the origins of the tick possibly be, the tick's introduction into the U.S. be traced using the genome of the tick? Is there any way to trace where these ticks actually came from through their genetic makeup?
Um, Not that I'm aware of. Like I said, I know that, but like, I mean, the Haemaphysalis longicornis, it is the, in New Zealand, it is the only vector, but in Australia, it's not the only vector. And in like Asia, Japan, Korea, some of those, it's not the only vector either. It actually vectors through other ticks more common ticks in those regions, um, who have different, ecology and biology. I suspect that I don't know enough about genetics. I think it would be difficult given the number of ticks that I can imagine are in the world, given this thing's amazing ability to recreate herself.
Okay. An attendee asked, you mentioned Kansas and Nebraska. There was some importation of cattle into Kansas and Nebraska.
And
Where
that
were
is,
these cattle imported from?
um, the Nebraska one did not say. I do believe that the one of the Kansas ones I read, and again, like I said, this is just like searching the web. Like not a lot of this stuff is put out there. You have to just kind of search and find all these little announcements from different states and stuff. And you have to double check them because the AI is wrong, by the way. It will give you wrong information. But I believe that the first Kansas was a load of cattle from Virginia. Not surprising.
Okay. And then kind of on the treatment aspect of cattle and the clinical disease, is there any variation in breed in positive and or clinical animals? And do we see any difference between different cow breeds?
No, we haven't. And I actually tried to look at breed at the bull test because that's where, they're really obviously most of the cattle in Virginia are, some sort of Angus commercial cross. Most people that are really raising cattle, we don't have a lot of breeding stock. We have more, commercial cow calf type things. And so they're primarily Angus, they're primarily black. But at the bull test, I didn't see any numerical differences for sure. But I don't have the only other one I had enough really numbers on to do data was the Simmental, and I certainly didn't see any difference in those. But the other breeds like Herefords and Gelvies and stuff, I didn't honestly have enough numbers to trust the data, but numerically there's no difference. Um, in terms of what I've heard from people, no. But again, like I said, in Virginia, we kind of have a lot of just your typical black commercial, probably 60% Angus cattle. So I don't know about like it'd be interesting to see if like the Texas down south long skin, not Taurus, the other one, Bos Indicus. Sorry. It'd be interesting to see what the Bos Indicus cattle would do with it. But we don't have enough of them here to know, for me to know.
All right, and then the last question of the day, with regard to treatment of clinically ill positive cattle, how are they treated? And also, are positive cattle treated to clear infection even if they are not clinical?
No, positive cattle or not, you cannot clear it. Nothing works. Even buparvaquone doesn't clear it. No antibiotic clears it. Buparvaquone doesn't. They tried that in ours. Um, basically we don't know of anything that will clear this thing. But again, not surprising. I mean, even anaplasm isn't clearable once they become a carrier. So because these are all intracellular, so it's just really hard to get in there. Um, if you have an acutely clinically ill cow who's very sick, um, for the most part, by the time, particularly if she's beef, by the time you find her, she will need a blood transfusion. She will need a blood transfusion because her PCV is down in 8, and that's generally not compatible with life. Um, but if you give them a blood transfusion and baby them, they will live. They will carry it forever, but you can get them through it if you catch them enough. And that's in New Zealand, since this started in the dairy, but they have pastoral dairy, they did a lot of blood transfusions in the beginning. But they look at those cattle, even though they're pastoral cattle, they get milk twice a day. The problem is in the cow-calf operation, for the most part, those producers out there looking at those calves through binoculars and counting and being like, yep, they're all here and they're all getting up and walking to the feed bunk. We're not out there enough to catch them before they get to that 10% PCV to be able to get on them, just because we don't operate with our beef cattle that way. But if you need to save one, they just did one back at Virginia that it was a breeding. I mean, she was a show heifer, um, and they saved her with a blood transfusion, so it can be done.
Okay. Well, one more question popped in, and I told you it was the last one. Well, now it's the last one because it's an interesting question. Someone asked if meat and blood products from positive cattle are safe for use by humans and animals for feed, pharmaceuticals, etc.
Yes, as yes, and that's according to the WOAH. It does not transfer in that way. The meat safe, all those type of things are all fine. Um, and I would assume the same about like the byproducts. And I don't know when you start getting into some of the ones that are like used for pharmaceuticals, but definitely the meat, the milk, your standard consumable products are fine. And actually, Theileria, it doesn't even, I don't even think sheep can actually technically get it. We thought maybe one did once, but if they get it, they like get it and it's gone. Like they clear it, it's gone. It's not really there. But it does nothing for humans. It really is just cattle, not even other ruminants. And it's nothing for humans. Now, the Asian longhorn tick, however, the longhorn tick has been found to have a couple of things like powassan and some of the other like weird zoonotic human diseases that are not so good, but it's not Theileria. Like powassan virus, I think is the one.
Well, I want to thank you, Dr. Gwynn, for a very informative and engaging presentation. I think it was very well received. I saw some hearts and clapping hands and everything coming up a little while ago, and here's some more. So we definitely appreciate your time and your
I forgot
presentation.
one other thing. If any ACBPM members or the other members in the other organizations would like to give a CE webinar, we have if you just go to the ACBPM website, there's a form you can send in, or you can email Dr. Turing at the admin@acbpm.org, and he will let us know, and I will grab you for a seminar.
That was going to be my next push to get volunteers. And then also, so with that, I want to wish everybody a great day. Any final comments, Dr. Gwynn? Dr. Gwynn is also the incoming chair of the Continuing Education Committee for ACVPM. So any final comments?
No, thank you. And yeah, feel free to volunteer to speak. We like to hear what everybody's doing. Thank you.
Great. Well, thanks everybody for attending, and everybody have a great evening or rest of your afternoon. Thank you very much.